Dear friends, welcome back to Data Analytics Talks. Thank you very much for all your support. This is our eighth session under the learning series, Becoming an Azure Data Engineer. In this session, we are going to discuss different file formats that every data engineer should be aware of. First of all, let me ask you a question. Why do we need so many file formats? You have come across CSV file, JSON file, ORC files, AVRO files, Parquet files. So why do we need all these file formats? You know, with an estimated 2.5 quintillion bytes of data created daily in 2022, a figure that is expected to keep growing, it's paramount that methods evolve to store this data in an efficient manner. While JSON and CSV files are still common for storing data, they were never designed for a massive scale of big data and tend to eat up resources unnecessarily. For example, JSON files with nested data can be very CPU intensive. They are in text format and therefore human readable, but they lack the efficiencies offered by binary options. So as data has grown, file formats have evolved. File format impacts speed and performance and can be a key factor in determining whether you must wait an hour for an answer or milliseconds. So matching your file format to your need is crucial for minimizing the time it takes to find the relevant data and also to glean meaningful insight from it. So there are two main ways in which you can organize your data, rows and columns. Which one you choose largely controls how efficiently you store and query your data. So in row format, the data is organized by a record. Think of this as more traditional way of organizing and managing data. All data associated with a specific record is stored adjacently. You can see that the column ID, first name, last name, city, age, they are stored adjacently because they are all part of a record. In other words, the data of each row is arranged such that the last column of a row is stored next to the first column entry of the succeeding data row. So when it comes to the columnar format, the values of each table column are stored next to each other. This means like items are grouped and stored next to one another. Here you can see that the values of a column ID, values of column age, they are stored next to each other. So within fields, the read in order is maintained. This preserves the ability to link data to records. So traditionally, you can think of row storage this way. We have the first row, we have the second row. But you can also represent raw data visually in the order in which it would be stored in memory, like this. So the first row, then as a continuation, second row. So comes to columnar format, you can think of columnar storage this way. ID, first column, last name, city, and age. And you can also represent column data visually in the order in which it would be stored in memory like this. So the first ID, all the values of IDs are stored next to each other. Then first name, last name, city, and age. So choosing a format is all about ensuring your format matches your downstream intended use of the data. So optimize your formatting to match your storage method and data usage, and you have optimized valuable engineering time and resources. So looking at the particulars of row formatting, with the data in row storage memory, items align in the following way. So you have the first row, you have the second row. So you can append any newly acquired data to the end of the current data set. So we have the two records. Then we can append a new record at the end of the data set. So our writing to the data is relatively cheap and easy in this format. Row formatting is recommended for any case in which you have write-heavy operations. However, read operations can be very inefficient. So here is an example. Obtain the sum of ages of individuals in the data. This simple task can be surprisingly compute intensive with a row-oriented database, since edges are not stored in a common location within the memory. You must load all 15 data points into memory, then extract the relevant data to perform the required operation. So you need to load all these 15 data points, then extract the edges of these resources, then finally do the calculation. Yes, it is surprisingly compute intensive. So you must load all the data in all the disks to obtain the information necessary for your query. If each disk is filled to capacity with the data, this can easily require extra memory utilization and quickly become burdensome. So that said, row formatting does offer advantages when schema changes. In general, if the data is wide, that is, it has many columns and is write heavy, a row-based format may be best. So coming to the columnar formatting, the data is grouped in terms of like columns, ID, first name, last name, city, age. So writing data is somewhat more time intensive in columnar formatted data than it is row formatted data. Instead of just appending to the end of the row format, you must read the entire data set, navigate to the appropriate positions, and make proper insertions. So navigating to the appropriate position for insertion is wasteful, but the way data is partitioned across multiple disks can alleviate this. It still takes a large amount of memory and computational time writing to 5 separate locations to add a data for a third individual. However, you are simply appending to the end of the file stored in each of the location. So the columnar format does not compare favorably to row formatting with regard to write operation, but it is superior for read operations such as querying data. So take an example. Obtain the sum of ages for individuals in the data. To accomplish this, go to a storage location that contains information on the ages, that is just the disk 5, and read the necessary data. This saves a large amount of memory and time by skipping over non-relevant data very quickly. So in this case, all reads came from a sequential data stored in a single disk. The efficient querying is not only the reason columnar format data is popular. The columnar formatted data also allows for efficient compression. So data retrieval and compressions are the two factors that makes the columnar data more attractive. So why we discussed about row format and column format? The answer is because the file formats that we are going to see adopt one of these data organization approaches. For example, CSV organizes data using row format. Parquet file follows columnar format. So let's look into each of these file formats quickly. So this is the CSV file format. CSV file provides a simple and efficient way of storing and transferring data between different applications. The CSV stands for comma separated value files or comma delimited files. They're one of the most common format for spreadsheet programs. So CSV files are plain text files where commas are used to delimit or separate data. Because the CSV files provide a simple and standardized format that can be easily read and processed by most software applications, they are widely used across multiple industries to exchange data. So the major delimiters are semicolon, pipes, tabs, quotes. And when are we normally use CSV files? Because CSV files are designed to be relatively simple, they are frequently used across a wide range of industries to transfer complicated data between applications. With CSV files, it is possible to export complicated data from one application to a CSV format and then import that exported CSV data into another application where it can be used. So please spend some time exploring CSV file and its benefits. The next file format that we are going to see is JSON. Is very common. A JSON file is a file that stores the simple data structure and objects in JavaScript object notation JSON format. which is a standard data interchange format. It is primarily used for transmitting data between a web application and a server. A JSON files are lightweight, text-based, human-readable, and can be edited using a text editor. JSON uses a hierarchical structure of nested key-value pairs. JSON is not typically used with spreadsheet applications like Microsoft Office, OpenOffice, or Google Sheet. So if you are not familiar with JSON, please have a look at the JSON file format, how the data structure is managed and organized in this file format. So you can see these are objects, and each object has some properties like ID, category, name, author, and so on. Since the format is textually, JSON data can only be sent between computers and used by any programming language. The JavaScript has a built-in function to convert JSON string into JavaScript object, json.parse. So moving on, we have a different file format. Sometimes it is new to many of you. It is AVRO. An AVRO file is a data file created by Apache AVRO, an open source data serialization system used by Apache Hadoop. It contains data serialized in a compact binary format and schema in JSON format that defines the data types. AVRO files may also store markers if the data sets are too large and need to be split into subset when processed by Apache MapReduce in Apache Hadoop. AVRO was developed within the Apache Hadoop project, which is an open source platform used to store and process structured, semi-structured, and structured data without any format requirement. AVRO is utilized in Apache Hadoop as a serialization format for persistent or infrequently accessed data. Since its data is stored in a compact binary format, the AVRO format is especially useful for the exchange of extremely large data set. And AVRO file format is a row-based repository configuration that can be used for Hadoop. Then some of the ideal use cases for AVRO are write-heavy operations due to serialized row-based storage. Then when writing speed with the schema evolution, adaptability to change in metadata is critical. So coming to the next file format, it is the ORC, Optimized Row Columnar. Is an open source columnar storage file format originally released in early 2013 for Hadoop workloads. So ORC provides a highly efficient way to store Apache Hive data, though it can store other data as well. It is a successor to the traditional record columnar file. ORC was designed and optimized specifically with Hive data in mind, improving the overall performance when Hive reads, writes, and processes data. So some of the use cases for these ORC file formats are when reads constitute a significantly higher volume than writes, when you rely on Hive, when compression flexibility or options are key. ORC files are organized into strips. Each strip consists of an index, a row data, and footer. The footer holds key statistics for each column within a stripe, count, min, max, sum, and so on, enabling easy skipping as needed. The footer also contains metadata about the ORC file, making it easy to combine information across strips. So finally, we have the Apache Parquet file format, which was first introduced in 2013 as an open source storage format that boasted substantial advances in efficiencies for analytical querying. Apache Parquet is a file format designed for efficient data storage and retrieval. It provides efficient data compression and encoding schema with enhanced performance to handle complex data in bulk. Parquet files support complex nested data structure in a flat format and offer multiple compression options. Parquet is broadly accessible. It supports multiple coding languages including Java, C++, Python. This makes it usable in nearly any big data settings. As it's open source, it avoids vendor lock-in. The Parquet files are composed of row groups, header and footer. Each row group contains data from the same column, and the same columns are stored together in each row group. Parquet files are often most appropriate for analytics or LAP use cases, typically when traditional OLTP databases are the source. They offer highly efficient data compression and decompression. They also feature increased data throughput and performance using techniques such as data skipping, in which queries retain specific column values and do not read an entire row of data, greatly minimizing input output. So, what are the ideal use case for Parquet file format? Storing big data for any kind, structured data table, images, videos, documents, ideal for services such as AWS, Athena, and Amazon Redshift Spectrum, which are serverless interactive technologies. A good fit for Snowflake as it supports extremely efficient compression and encoding schema. When your full dataset has many columns, but you only need to access subset. So when you want multiple services to consume the same data from object storage. Finally, when you are largely or wholly dependent on Spark. So these are the scenarios that we will go for Parquet file format. Thank you very much for watching this video. I hope you got an understanding on how data is being organized in files, mainly the row way and the column way, and what are the major file formats like CSV, JSON, Parquet, ORC, and finally AVRO. Thank you. Thank you very much for watching this video.